So discussion of the pop quiz. This was a pop quiz that was related to refraction of the light. So refraction of the light. So we have a monochromatic light which is incident on the rectangular glass block. Some of the light is reflected and some of the light is refracted as shown. Which of the following property does not decrease when the light is refracted? So during a refraction, what will happen? The frequency, because frequency does not change. The speed will change, the wavelength will change, but the frequency does not change. So frequency will remain same. The intensity, the amount of a light, which because partial reflection and refraction, so amount of a light or the intensity of the light will change. The speed will change as it was moving from air to glass. The speed will decrease and wavelength will decrease, but the ratio between speed and wavelength does not change. That's why the frequency remain constant. The question 2, the diagram shows a ray of a light traveling from a fish to an observer. The ray of a light is refracted at a water to air boundary. Determine the refractive index. You should take measurement from the diagram. So if we want to determine the refractive index, we will use a Snell's law. What is the Snell's law? According to Snell's law, N1 sine theta 1 equals to N2 sine theta 2. So N1 is a refractive index of the first medium, N2 is a refractive index of the second medium, theta 1 is the angle in the first medium, and theta 2 is the angle in the second medium. So we have to measure these angles using a protractor, like say one of the angle is, say this angle is 65, but with a measurement it should be done, and say this angle is 43. So we'll just substitute refractive index is 1, then it will be sine 65 equals to refractive index of the second medium, which is n, and sine 43. So we just simplify for sine for n, so it will be sine 65 over sine 43. That will give us a value of n, which is about 1.33. And there will be no unit because the refractive index is a ratio, so it does not have any unit. The next question, the diagram shows light from sun reflected from a water surface into an eye of an observer, and the reflected light is partially polarized. Explain the difference between a polarized and unpolarized light. And then reducing the intensity of the reflected light would help to see the fish. How observer can use a polarizing filter to reduce the intensity. So first thing, what is the difference between the polarized and unpolarized light? This you have to learn the standard definition. One is unpolarized light, which has a vibration or oscillation in many planes, and the polarized light has a vibration or oscillation in only one plane, and that include the direction of travel. Remember one thing, if you use the term plane, then you should mention it involve the direction of travel. So the standard definition for unpolarized light, which consists of vibrations or oscillations in many planes, whereas polarized light has vibration in one plane, which include the direction of travel. So there is a, in the direction of a travel also it is vibrating. So when you use the term plane, then this should be the definition. But sometime you can also use the term So if you mention like unpolarized light has a vibration or oscillation in many planes or all planes, and polarized light is having a vibration in one plane that include the direction of travel. Or you can say unpolarized light has a vibration or oscillation in many planes, when polarized had vibration or oscillation in one plane which is perpendicular to the direction of a wave travel. So 1 mark is for mentioning unpolarized light consists of many planes. 1 mark for polarized light consists of one plane. And the second mark for this one, like total 3 marks are there. So one, two, and third mark, which include the direction of travel. Then reducing the intensity of a reflected light would help the observer to see the fish. How the observer can use a polarizing filter? So what actually happened? So some of the light is light from the source, some of the light is refracted, and some of the light is reflected. The light which is reflected is partially polarized, which is horizontal polarized. So we are receiving both of them. We are receiving the inner light. So we have polarized and unpolarized lights are there. We want to cancel out the reflected part. So how we can cancel out the reflected part? So we can first thing, light which is reflected from the surface, it is partially polarized. Like there are other component, but one of the component is major. So what we can do, how we can limit this, if we use a vertical polarizing filter, a glass or a polarizing filter which is vertical, so this it will block. This component will be blocked. Only one component will pass through from the fish. So as a result, we are able to see the fish, but we are not able to see anything which is reflected. So the light which is reflected from the surface is partially polarized. So we can place a polarizing filter 90-degree or perpendicular to the partially polarized light. So as a result, no light will be transmitted, and we'll only observe the component which passes through a polarizing filter. We'll only see the component which is reflected from the fish and passes through a polarizing filter. So that's how it can be done. Is it clear? This was a pop quiz related to refraction of the light. Any question in this?